right, are you excited? We're flashing an LED like our Hello World program we did with the PIC, and it's a very similar process. Let's take a look at the Arduino and the blink code again to see just how similar it is. Now, the reason I said not to change anything in the code yet, except for the delay, was because just like the PIC, each pin of the Atmel microcontroller can have multiple functions. So if you had changed, say, the pin that you performed the digital write on, it wouldn't have worked for two reasons. One, you don't have an LED on that pin because there's only one LED pre-installed on the board. Two, notice only pin 13 was set up as a digital output. Right there at line 20. So just like the PIC, the Atmel pins can have multiple functions. It could be a digital input or a digital output, or it might have the option of a pulse width modulated output, or perhaps a digital to analog converter, or maybe an analog to digital converter. So just like on the PIC, we had to set up the pins. You remember setting up the tri-state register. We'd set up the bit corresponding to a pin on a port as either a 1 for an input or a 0 for an output. Well, it's the same idea here. We tell it we will set up the pin mode for pin 13, and we'll set it up as an output. Now, how about we change that to 12? So now, pin 12 is set up as a digital output. Then, just like in the PIC, we can send a high or a low to that pin. So let's come down here and change the 13s to 12s. So we are writing a digital high and then a digital low to pin 12. So if you look on your board, you can see they have all of the pins conveniently numbered for you. So if you just flash your altered program to the board, really nothing will happen except the onboard LED will stop flashing. However, if you put an LED from pin 12 to ground, you'll see that the output, that output is now pulsing. Now, don't forget your current limiting resistor. This is an LED, and if you just stick an LED straight onto that port, you'll fry both the LED and your Arduino, and we don't want that. So these ports can be used just like a breadboard. Just stick a wire into pin 12, jumper out to your breadboard and your LED's positive lead, then run your LED in series with, say, a 200 ohm to a 1K ohm resistor, which jumpers back to ground on your Arduino. Now, conveniently, I have a whole mess of these LEDs for workshops, which come with a resistor already built in. So I'm running the positive wire into pin 12 and the negative wire to ground, and you can see the pin 12 is now flashing the LED. So let's take a look at the layout of the code. You'll remember almost all of our PIC programs were laid out in a similar fashion. We had a whole series of lines which set up the PIC for use. It set up the ports, how we wanted to use them. It set up the clock speed, which we cannot do on the Arduino, just FYI, etc. Now, this setup, we typically only did once, right? Then we almost always had a main loop in our program, a part of our program, or the entire program itself, which we just ran over and over and over again. Well, it's the same with the Arduino. We set up functions. Now, what's a function? Now, like anything that has a function in life, it performs a function. It does a job. In this case, the first function is setup. We only run this code once, and everything you want run once goes in between this open brace and this closed brace. The braces mark the start and the end of that function. Now we'll explore this little void a little more later on, but for now, let me just explain that if we had a robot that performed a function, it can go and perform a certain job. Now maybe that job is to go and wash your car. So it goes and carries out its function. It washes your car and then comes back when it's done, ready to carry out its function the next time you call it. Or perhaps the function was to go and get the newspaper. So when the robot comes back from its function, it returns something from its function. It gives you something from that function, the newspaper. Well, in programming, our functions can sometimes go and do a job and might bring us back something. Reading from a keypad, or a temperature measurement it got during its function. Or it might not bring anything back. And so that's what this void means. It's a function, but it doesn't bring anything back for you. It just does whatever is in between the braces, and that's it. It does not bring anything back to you when it finishes this function. Now, the next function is a loop. Now, just like with the pick, if you so desired, you can design your program to run only once. But almost always, you are going to want to run a continuous loop, a main routine. Well, everything in this function, every line of code between the start brace and the end brace, gets run in a continual loop. So here it writes a high to pin 12, waits 1,000 milliseconds, writes a low to pin 12, waits 1,000 milliseconds, and this function is a loop, so it jumps back up to the open brace, starts from the top all over again, running the code. Now, if you still have the original window open from when you first started up the IDE, this one here, if you don't have this window, just go up to File, Examples, Basics, and Bare Minimum. Now, look at this code. This is the bare minimum that you need to have a complete program. This program does absolutely nothing, but you can compile it and even send it to your Arduino and it won't crash. Why? Because it meets the minimum coding requirements. You have to have at least a setup function and a loop function. Even if you have no instructions, you have to have these functions, even in their bare bones state. So if you wrote a program that you wanted to run only once, one of those ultra rare occasions, you'd write your lines of code between the open brace and the closed brace of setup. But you would still have to have the loop function, even if there was no lines of code to perform within that loop. You just have an empty loop. Now, a few last things, and then I'm going to kick you out of the nest to write your own program all on your own, because you guys are incredibly smart, and I know full well you can do this. Okay, come back to your Blink program. This is critical and will be probably the most common mistake you make. Notice that every line of code has a semicolon at the end. You have to have this semicolon at the end of every single line of code, as it tells the compiler that is the end of the line. If you forget it and try to compile it, it was looking for more code and instead ran into an instruction and crashed. You have to have that semicolon at the end of each line, but pay attention to the message bar. It told you what the error was, but also highlighted the line where it ran into the error, or in this case, the line after the actual error. But it helps you troubleshoot your program. Notice also that each line of code has to be indented, just like the pick programming, right? And last but not least, you can pepper your code with comments. Just like in MPLAB, comments are ignored by the compiler and you can write notes to self or other people, because this is Arduino. It's all open source, share and share alike. Now, you might choose to share your programs with others. This way you can leave notes, for others. So if you share your code with others, they understand what you did, how, and why. And so comments are marked with two forward slashes like this. Okay, time to spread your wings. Here's your challenge. From the analog electronics module, you should have some green, yellow, and red LEDs, as well as some resistors and a breadboard. So, break out some jumpers from your Arduino's ground connection and pins 13, 12, 11, 10, 9, and 8. Now you'll want two sets of LEDs like I've got here, but you can connect all of the LED negatives together and then run a resistor from there to the Arduino ground. Then run wires from positive of each LED to pins 8 through 13. And I'll leave that wiring up to you. I ran it so that this group of LEDs, the green, went to pin 8, yellow to pin 9, and red to pin 10. In this group, green went to pin 11, yellow to pin 12, red to pin 13. I then programmed the Arduino to turn the LEDs on and off in a timed sequence, and we get traffic lights. So this light is controlling traffic in one direction, this light is controlling traffic in the other. Simple, right? So, have at her. Your challenge, should you choose to accept it, is to program traffic lights. Or a light chaser if you prefer. Just light them LEDs up in some kind of animated pattern.